Okay, let's look at some examples on finding asymptotes, because honestly, if you can find the asymptotes, everything else is cake. It's super easy to determine. The asymptotes are what are going to drive your rational functions. So I want to find all asymptotes possible. So the first that we want to look at are vertical asymptotes. Now, how do you find a vertical asymptote? Yep, set that denominator equal to 0. Now this one, pretty much my best day ever, because the denominator is already factored. So I'm going to have 2x minus 1 equals 0 and x plus 3 equals 0. So for the first one, x is equal to a 1/2 because you add 1 divided by 2. And x is equal to a negative 3 because you subtract 3. So I have two vertical asymptotes where x is equal to a 1/2 and x is equal to a negative 3. Now remember, these are vertical lines. They're imaginary lines, so they're going to be dashed lines, but they're still lines. So make sure you have that x equals in there. All right, so now I can find vertical asymptotes, and here's the deal. It's either going to be a horizontal asymptote or a slant or oblique asymptote. We have to determine what is it. Yeah, it is a horizontal asymptote. Good. How do you know that? Yeah, well, if I'm looking at this, so you can see that you have your x's here, but are the x's the same? Do I have the same degree on the top and the bottom? No. Good. Tell me why. Yep, if I'm looking at the denominator, notice what's happening in the denominator. I have a 2x minus 1 and an x plus 3. So actually, I have an x in the top and a 2x squared in the denominator. Aha, very cool. Because when you multiply these together, you get your x squared. Watch for that trickster stuff. So if that's the case, now what is my horizontal asymptote? Yep, automatically y equals 0. If it's small on top, automatic y equals 0. Good. Okay, let's try another one. Okay, let's find all of our asymptotes on this guy. I have f of x is equal to 2x plus 1 and x minus 3. So the first thing we want to look for is a vertical asymptote. And where is that? X plus 3, right, where you have x minus 3 equals 0, so you plus 3, good. So x is equal to 3. I have a vertical asymptote at x equals 3. Good. Okay, now do I have horizontal or slant? Yes, horizontal again. Tell me why. Yep, I have the exact same degree in the top and the bottom. They're both x's, so I'm just looking at the coefficients. So my coefficient here is going to be y is equal to 2 because it's the same thing as 2 over 1. And you know when you write a whole number, you don't put it over 1. So we have a horizontal at y equals 2. Good. Let's try a couple more. Okay, take a look here. I have f of x is equal to x squared plus 1 over x minus 2. So very first and foremost, what's my vertical asymptote? Yep, you're getting good at this. Good job. X equals 2. How do you know x equals 2? Yep, because you set the denominator equal to 0, solve for x, and that's where x equals 2. Good. Do I have horizontal or slant? Yeah, we get our opportunity to find a slant asymptote. How do you know it's going to be a slant asymptote? Because the degree in the top is 1 greater. Now, let's do a little synthetic division. You don't always get to do synthetic division on these. However, the problems that I give you for college algebra, you will. When you get into your upper level mathematics, I'm pausing for dramatic effect here. So when you get into your upper level mathematics, you won't necessarily always have a sweet little synthetic division option, but we have to start somewhere, and that's where we're starting. We're building the base, and then you can build on it when you get into your higher math. But for now, with our slant asymptote, we're going to do a little bit of division here. So remember, it's always opposite of what's next to the x. So I have a 2 on the outside of my box, and I have a 1, 0, 1. Did I catch anybody on that? Because notice I don't have an x term in here. So when you do synthetic division, you have to put that placeholder in there. So drop the 1. 2 times 1 is a 2. Drop the 2. You have 4. This 5. That's fine. But remember, we're not really going to use that. My slant asymptote, I now have my slope and my y-intercept. So I get y is equal to a 1x plus 2 for my slant asymptote. Cool. You guys are getting this. Okay, let's take a look at this guy. Notice I'm going to be looking for vertical asymptotes, horizontal and slant that we have going for us. However, what do you notice about this guy right off? First of all, let's just take a step back here and talk about my domain. What's the domain of this function? Yep, negative infinity up to 3, union with 3 to infinity. And that's because if you set your denominator equal to 0, you get x equals 3. Now, I'm not just automatically going to call that a vertical asymptote because look at your problem here for a second. I have f of x is equal to an x squared minus 9 over x minus 3. Is there anything that's amazing about this x squared minus 9? Think factoring. Yeah, difference of squares. So what we actually have is f of x is equal to x plus 3, x minus 3, all over x minus 3. Yep, and in intermediate algebra, when you had those rational expressions, what could you do? Cancel. Yeah, but, this x equals 3 here, still not part of your domain. It doesn't just automatically go away. It is not a vertical asymptote. However, if you're looking at this problem, even though it's not a vertical asymptote, it is called a hole in the graph. So anytime you can simplify your rational expression, that becomes a hole in the graph. So a hole happens when you can simplify the denominator. So anytime you can simplify out that denominator, cancel that out, that gives you a hole in your graph. So my graph actually looks like that. It's a line of y is equal to x plus 3. And if I'm looking this at 3, oh, you know what, I should probably actually graph that. So here when x is equal to 3, I have a hole in my graph because that's not part of my domain. Now obviously this is not a well-drawn graph. I just want to make the point here of where the hole is. Good. All right. So if the denominator can equal 0, cannot be factored out, automatic vertical asymptote. If it can be factored out, that puts a hole in the graph. Good. Now let's make some actual rational functions using this information.